Hello and welcome to the video. This is our mechanism sessional final project. These are the team members Jay, Chaitanya, that's me and Pratham. I'll be showing you the overview of the project and the calculations and dimensions how we have figured out. Jay will be showing you the MATLAB code and the simulation in MATLAB, and Pratham will be showing you the simulation in SolidWorks. So this is the problem statement. Synthesize and make a simulator for the mechanized dumper truck door mechanism that opens as the bin tilts, taking into account the functional relation between the angle of opening and bin tilt angle. So basically, if this is the dumper truck, as the bin moves up, the gate should open up. The angle that the gate opens up should be in a relation should be in relation to the angle that the bin moves up with. So after some manipulation, we have figured out these values of the links L1, L2, L3, and L4. I'll show you the calculations which we have done. Suppose alpha max is equal to 70 degree. Alpha max is the angle which the maximum angle that the gate will make, which with CO, that is the maximum gate angle, and that will take place at the dead center configuration. Another assumption we have taken is L4 is equal to 100 mm. And another thing we have to notice, CG is always perpendicular to BC. CG is the gate, and BC is this link L3. And based on these assumptions, we have to figure out the values of L1, L2, L3. So at the dead center configuration, when alpha is equal to alpha max, we apply the cosine rule in triangle ACO. Now, after applying the cosine rule, we get this equation, this quadratic equation where x is L2 plus L3. L2 plus L3 is this link. It will be perfectly collinear because this is the dead center configuration. Now, for the roots to exist, discriminant should be greater than equal to 0. So we applied that condition and we get this inequality. L1 should be greater than equal to 34.2. Now, after we assume a suitable value of L1, we put it back into this quadratic equation, get the value of x. X is L2 plus L3. And we go to another configuration, which is when alpha is equal to 0. This is the initial configuration, and apply the Pythagorean theorem. And from these values of x, L1, and L4, we get the values of L2 and L3. Now, I need to point out something that if L1 is greater than 34.2, so any value above 34.2 should work. For example, if you put L1 equal to 35 in this equation, we get the values of L2 and L3 as negative. So we have to do some iteration, and the suitable value we have settled is 50 mm. So we put this value of 50 mm back into this equation, get the value of x. X is L2 plus L3. We get two values of L2 plus L3 because it is a quadratic equation. If you use the value of x is equal to 57.13, one of the lengths is negative. So we have to reject that. And we use the another value 130.44, get the value of L2 and L3. So in this way, we have found out all these values L1, L2, L3, and L4. Next, Next, we need to find out the relationships between beta and alpha because that's how we then we will be able to simulate in MATLAB and SolidWorks because this is the input angle, this is the output angle. These are all the relationships. I'll show you the proof of this relationship. This is again the kinematic diagram which I had shown you earlier also. We have to assume a coordinate axis where the origin is at 0, 0. This is point O, and the positive x-axis we have assumed to the right hand side. Now, if we write the coordinates of point A, that will be minus L, 0. Similarly, we have to write the coordinates of point C and point B. Next, we calculate the angle delta. Delta is the angle link BC makes with the horizontal. We calculate delta, we get it in terms of gamma and beta. Next, we need to find out the what is beta. So we write the length of L3 in terms of XC, the coordinate in terms of coordinates of B and C. We do some manipulations and we end up with this equation a sine beta plus b cos beta equal to c, where a, b, c are appropriate constants. We put cos beta and sine beta in terms of tan beta. We get this quadratic equation and finally we figure out what is beta. And a, b, c are this constant. Next, we need to find out what are the relationships. What is the relationship between gamma and alpha, the input angle and the output angle. So this angle is always 90 degree. So if this angle is gamma, this angle will be 90 minus gamma, and this angle is alpha, which is the angle CM makes with the gate. This angle will be 90 minus alpha because we have mentioned that BC is always perpendicular to CG. Now in this triangle BMC, if we know delta and we know 90 minus alpha, we can figure out x from the summation of angle property of the triangles. And these two lines are always parallel, so summation of these angles will be a 180 degree. From that relation, we can figure out what is alpha. Alpha is equal to gamma plus delta. That's all the relations we have written here. Next, if we plot these relationships, use these relationships into MATLAB and do the simulation, we get this curve where this is the bin, this is the gate. We can see as the bin moves up, the gate opens up, and the relationship between the input angle and the output angle is kind of linear. This will be shown in detail afterwards by Jay. And finally, we do the SolidWorks simulation. This will be shown by Pratham later. Thank you.
Hello everyone, myself Jay Giwala. I will walk through the logic of the medley simulation. First, I will walk through the logic, and then after I will run the simulation. The script starts by defining all the dimension of the mechanism: L1, L2, L3, L4, the gate length and the container length. These constants represent the physical geometry of the dump truck linkage. The parameters A and B are simply dividing the container length, so the actuator mount points can be placed accurately on that. Uh, next we will have the input range for theta. The bean rotation angle is defined. The entire mechanism is solved for each of these angle inside a loop. Next, we will walk through the loop for the position analysis. Inside the loop, there are three terms A, B, and C, which are computed. These come from rearranging the loop closure equation, which we already discussed in the. Using them, the scripts calculate beta, uh, which is a secondary link angle, and theta 1, which is nation of the rotation transmitted through the gate. Once this angle are known, the code reconstruct the coordinates for each point O, A, B, C. The extension point PQ, actuator point A1, A2, A3, and finally the gate tip G. All of this is done through straightforward trigonometric relation, which we already discussed in the slides. After computing the positions, the script plots the mechanism for that frame. The figure is cleared, which time so the movement stays clean. Links are drawn as simple line segment. Joints are markers, and short pause producers as animation effect. That is the core logic. We will compute the geometry, update the coordinate, and we will render each frame for that coordinates and geometry. Now let's run the script so we will have a detailed idea what is going on here. So yeah, here you can see the animation, which is the full kinematic response of the linkage as the bin rotates. You can clearly see uh, how the connecting rod, the gate bar, and the actuator coordinator coordinates the door while maintaining the proper geometry. Uh, Now there is another code which is for the plot. This is the final result: a plot of the input bin angle versus the gate opening angle. The graph is essentially the functional performance of the mechanism. It tells you exactly how the door opens relative to the bean rotation, whether the linkage gives a smooth and controlled response or not.
Hello, my name is Pratham and today we'll take a look at the SolidWorks part of our project number 3. First, I would take your attention to the model part of our SolidWorks before the motion study. Now, in this model, we'll take a look at the rear part of our dumper truck rather than the whole body because we care about maximizing the door angle. Great. Now we have 4 parts in this model. Let me explode the model to show you all the 4 parts. First, we have the truck chassis. The truck chassis acts as the ground on which the whole model is based on. Second, we have the dumper bin. The dumper bin will move its angle based on the input given by the third part, that's the truck actuator. Now the truck actuator will move up and down, and this will cause the third link to move. And as a result, we have the fourth linkage, that is the truck door that moves it. And we have to maximize the angle of this truck door. Great. Now that we have seen all the 4 parts moving, let's collapse the body and take a look at the motion study. Great. Now we have the motion study in which you can see that as the truck input actuator moves, we have the dumper bin moving, and as a result, the door moves. Now the motion at which this stops is the dead center configuration, and all the dimensions for each of the linkages that has been done was done using dimensional analysis. Great, that's all from my part.